Hello everyone, in this video we're going to learn about binary tree, yet another kind of data structure. Here you see three trees, T1, T2, and T3, which are binary trees. But let's see that what do we mean by a binary tree. So binary tree is a kind of or a special case of trees which each node at most has two children. So at tree T1, the node N1 has exactly two children, N2 and N3. The node N2 has only one child, and the node N4 and N3 are the leaves, and they only have then they don't have any children. So again, if you have watched my previous videos that I have talked about the trees, so a tree in general again is kind of this structure that we have a root, which is the main or the very first node of the tree, and then every node is connected to all other nodes through this like the links or chains. We can use some sort of like the linked list data structure in order to implement a tree. Here I have part of like the implementation of the binary tree. So the class binary tree, again, I'm using here the like in my other videos, I'm using a Java format like the implementation. So we have a generic class, and the root node is the main node of the binary tree, and the class node itself or the structure node itself is the data of type T. Again, is a generic type that will be assigned later. And then we are keeping the left and right children. So, and also we can keep the parent node. In many or in some textbooks or resources, they might say that we don't need to keep the parents, but actually going to help us to traverse back to the parent node like easily. So we're going to keep the left child, the right child, and the parent of the node at any time. And as it's going to be very obvious that the root node will be the only node without the parent, or in other case the root parent will be equal to, or will be set to null value. So here T2 and T3 are two more trees. As you see, T2 only has only one node, which is N1, and also T3, which has three nodes, and it is a complete binary tree. So we're going to talk also about the complete binary trees, although I have explained the complete binary trees in another video, and some interesting features of the complete binary trees. So a complete binary tree is a tree in which every node except the leaves have exactly two children. So as you see here, the only tree that is complete is tree T3, because N1, which is root, has exactly two children, but N2 and N3, which are the leaves, they don't have any children. So T1 and T2 are not complete because N2 has only one child, and also T2 is not complete because it only has we only have the although we can just also say that it's complete because there's only the root itself, complete of let's only one node, some sort of like the complete binary tree. So T2 and T3. So again, there are very interesting features of the complete binary trees, or the like the number of nodes in a binary trees. So as you see in a binary tree, at each so starting from the very first level of the tree, which is here, this is the level 0, and we only have one node here. So the number of nodes is 1 here, or the maximum number of nodes. As we go further, so here we have the two children, or two nodes, because each node can have at maximum 2. So at the level 1, we have at maximum 2 children. Okay, so it is, I'm saying that less than equal to 2 means that the maximum number of children is 2. So here, look at the T1. Although these children does not exist, but I'm assuming that they are here. So there are some imaginary like the children here, and yet another one here. So as you see, the maximum number of children in the level 2 of a binary tree is 4. So the number of nodes is 4. So at level 2 we have 4 nodes. So then again, that's the maximum number of nodes that we have. So simply we can say that in a, and what's the height of this tree? In the T1, the height of the tree is 3. So that's at the height or level 1, 0, and then is level 1 and 2, but the height of the tree is 3. That's the number of nodes that we have from the root to the depth of the deepest node, which is in this case is n4. So what we can write, as we know that this is the number of nodes, the maximum number of nodes. So I'm going to write maxed number of nodes is equal to 1 plus 2 plus 4 plus, as we're going to be double, so it's going to be 8 plus, and we're going to increase it up to the 2 to the power h minus 1, and it is the h is the height of the tree. So here we have the height of tree is equal to 3. So the maximum number of nodes will be equal to 1 plus 2 plus 2 to the power, so 2 to the power 1 to the power 2. And as we know that 1 itself is to the power 0, so maybe it's better to actually replace 1 with 2 to the power 0. And that's going to be 7 for if height of the tree is equal to 3. So yeah, that's the number of like the maximum number of nodes in a complete binary tree. Again, in a separate video, I have talked more about the the complete binary trees.